So let's look at problem 17 here. There are different ways to solve this particular problem, and I will discuss it from two different ideas, both of which we kind of discussed them in class already, but you may not see how we can use it this way, so let me repeat it. So first of all, we can try to solve this problem directly. Well, idea number one. So what we can do is just to say, hey, why don't we try substitution? Because clearly this is a limit question. So if you try to do substitution, it's 1 minus 1 over 1 minus 1, which is a 0 over 0 type. So intuitively, I want to factor it. And because x approaches 1 makes my numerator and denominator to be 0, clearly I will end up with x minus 1. This term, x minus 1, is supposed to be a factor of my numerator. So the question actually is, sorry about that, something wrong with my Apple Pencil today. So x to the 900 minus 1 is supposed to be x minus 1 multiplied by something. And the question is, what exactly is supposed to be this something here? When we try to prove the derivative of the power function, so the power rule derivation we went over in class, we have shared a formulation for you. So if n were a positive integer, then a to the power of n minus b to the power of n is supposed to be a minus b multiplied by, okay, here's the interesting part. Sorry, my pencil is not really working well. A to the n minus 1 plus a to the n minus 2 times b plus a to the n minus 3 times b squared. So it's clearly going to keep decreasing power of a but increase the power of b. And then we end up with a to the power of 1, b to the power of something is going to keep increasing. And then a is going to disappear. B reaches the highest order. If you think about it, the highest order of a must be produced by multiply of those two terms. And the highest power of b must be generated by multiplication of those two terms, which gives me that. It must be n minus 1 here. So the previous term, where you see the power of b is going to increase by 1 at a time. So if it reaches n minus 1 here, it must be n minus 2 here. So this is what we have as the factoring. Well, you may say the original problem was not x to the 900 minus 1 to the 900. But if you think about it, 1 to the power of 900 is identical to 1. Therefore, it is a to the n minus b to the power n power structure. So we can factor it with the following formulation, where a represent x, b represent 1, and n represent 900. So I could write my function as a to the 899 plus x to the 898 times the b, and then x to the 897 times b squared, and so on and so forth, and x to the 1 to the 898 plus 1 to the 899. So I managed to factor my numerator. Therefore, my original limit question is going to be changed into x minus 1, multiply this whole expression here, divided by x minus 1. So my limit problem is going to be simplified as x approaches 1. So I'm replacing all the x by 1. So what I end up with is 1 to the 899 plus 1 898 times 1 plus 1 897 times 1 squared, and then 1 to the 1 to the 898 plus 1 899. So that's a lot of 1 adding together. So the question left for you to figure out is exactly how many terms do I have. So we can do a quick counting here. Well, clearly my power of x is decreasing from 899 to decrease by 1 at a time until it decreases to 1. So starting from 899, I have every single integer that goes smaller than this until 1. So that's 899 terms. But this is 899. There's another term which I failed to count. So altogether, that's 900 terms. Therefore, I'm expecting to have 900 of 1 here. So my final answer is supposed to be 900. So this is one way we can solve this problem, which is by factoring it. And you may see, well, there's a hint in the problem, and the hint says we can try to use the idea of derivative, and how are we supposed to solve it by that? Well, some of you learned the L'Hopital's rule. You can use L'Hopital's rule, which is not something we've discussed in class. So I'm not going to discuss that. The second idea is to solve it from the derivative point of view. We have two definitions of derivative. One of it is the derivative at a point is limit x approaches a, f of x minus f of a over x minus a. This was our first definition. And then we have the second definition. If I were to write x to be a plus h, because x is slightly, like, is very close to a, so x minus a is h, x approaches to a is the same, the difference between x and a is small, it's 0, so it's the same as f of a plus h minus f of a over h. You must be familiar with the second definition. Well, the first definition is mathematically equivalent to it, and what I'm trying to say here is let's just put the original problem that's given to you here side by side. So I have limit x approaches 1, I have x to the 900 minus 1, and I have x minus 1 here. So if you compare it, both x approach to a fixed number, it's the difference between x and that fixed number. So if I could have this match with that and this match with that, then we're all set. So is that possible to have f of x be the same as x to the 900 and f of a being 1? Well, as a matter of fact, we can. All we need to do is to let a being 1, then f of 1 is 1 to the 900, which is 1. So yes, this is equivalent to that, given f of x being x to the 900 and a being 1. So the original limit question is equivalent to f prime of 1. Well, if f were x to the 900, you've learned the power rule. The derivative of it is 900 x to the 899. Therefore, f prime of 1 is 900 times 1, 899, which is 900. So you can see from the derivative point of view, we can also solve this problem. We're literally comparing the limit notation with the limit problem. So I can solve the limit discussion with the help of the derivative definition. And we took the shortcut of derivative formulation so as to find our answer. So that's to solve it in two different ways. My final answer for this particular problem is 900.